それでは続きまして同じく台湾から台北ミニシパルリンシャンハイスクールからお越しいただきましたジャン・ユイチェンさん、ジェン・カイジェンさん、ヤン・ジェンルーさん、指導はチェン・メンジー先生です。それではどうぞよろしくお願いします。
Good afternoon, ladies and gentlemen. My name is Mercedes.
My name is Zhang Yuchen.
My name is Yang Jieru. We are from Lishan Senior High School, located in Taipei, Taiwan. Today, the topic we are going to introduce is the development of test strip using butterfly pea extract as an indicator. In a recent news report, people have been talking about a popular multi-layer drink. Tea shops claim the layer colorful were not made by artificial food coloring but natural substances contained in butterfly pea flowers. Butterfly pea flowers are added to the drink, making them colorful to catch consumers' eyes. Interested in such a phenomenon, we started to gather some information and found the butterfly pea flower contained anthocyanin.
Colorants as food additive makes food more attractive, and most of them are from nature, such as plants, animals, microorganisms, and minerals. Anthocyanins are natural colorants which have gained a growing interest due to their extensive range of colors and beneficial health effects. Anthocyanin with carbon-6, carbon-3, carbon-6, carbon skeleton belongs to the flavonoid family. And butterfly pea flower is a popular and easily obtained source of anthocyanins. So we decided to take this advantage of this feature to do the experiment.
We have three main experiments. The first one is the preparation of butterfly pea flower extract. The second one is the color change in different pH values, including the UV visible spectrum and application on acid-base titration. The last one is the butterfly pea flower pH test strip.
The way we extract the butterfly pea flowers was taking the butterfly pea flower 10 grams and extracting it to death with 100 millimeter distilled water and 70% of alcohol, respectively, at 4 degrees Celsius. And we use butterfly pea flower extract to observe the color change in different pH values. We found out that the colors in strong acid and strong base are more obvious than in the weak acid and weak base.
At pH about 2 to 5, the color of extract changed from purple to blue. Absorbance at 574 and 617 nanometer increase when pH values increase. The solutions contain the blue neutral quinonoidal base. That is why it expects blue. At pH about 8 to 11, the color of the extract changed to blue-green because of the blue neutral quinonoidal base and anionic quinonoidal base got equilibrium. The absorbance at 395 nanometer is higher than that at 629 nanometer. At pH about 12 to 14, the color of the extract changed to green, yellowish green, and the Statistics show that the absorbance at 580 to 680 nanometers are rather low.
The extract that at pH 1 to 5, color changing will be affected by the content of the red Flavian cation and the blue neutral quinonoidal base. When it got equilibrium, it produced the purple solution.
Compound A is the endocyan in the strong acid, and compound B is the endocyan in the weak acid. Compound C is the endocyan in the weak acid. Compound D is the endocyan in the strong base.
We use the extract, phenolphthalein, and the red cabbage to be the indicator and applied on acid-base titration. When acid-base titration reached equivalent point, the color of extract turned green into blue, and phenolphthalein turned pink into colorless. The red cabbage turned yellow into pink. Please watch our video above. This one we use the butterfly pea flower as an indicator. And the one below, we use the phenolphthalein as an indicator.
We made the experiment of testing equivalent point. The equivalent point of this experiment was close to the extract one. This and this. And as a result, butterfly pea was a good indicator on acid-base titration for its sensitivity. Easy handle as well, and environment friendly.
This page we are going to talk about butterfly pea flower pH test strips. The solution colors were not distinct from the pH test strips, and the test paper from 70% of alcohol extract were more recognizable than water.
We test the common solution by using the butterfly pea flower and universal test paper. The butterfly pea flower color changing in weak acid and neutral were not obvious, and now we know the butterfly pea flower test paper was effective.
At last, we made an experiment about stability of the butterfly pea flower pH test paper. The color expecting of the butterfly pea flower pH test paper, which stored at low temperature, was better than which stored at room temperature. The butterfly pea flower pH test paper are stable and easy to store.
Conclusion and future view. First, we successfully observed the color change of butterfly pea flower extract in different pH, and investigate the UV visible spectrum. Second, butterfly pea flower solution is a good indicator on acid-base titration and can replace the phenolphthalein. Third, we make a butterfly pea flower pH test strips to determine the level of acidity or alkalinity of the solution, and the pH test strips are stable and easily to store. Fourth, next, we hope to investigate the reduced ability of butterfly pea flower extract. Thanks to everyone. This is the end of our research. Thank you very much.
りがとうございました。では、ご質問をお受けしたいと思いますので、ご質問のある方、挙手をお願いいたします。はい、では真ん中の先生にマイクをお持ちいただけますでしょうか。お願いいたします。
Thank you for your nice presentation. I have one question. In your extract you obtained, a number of compounds would be involved. What do you think about the influence of the compounds other than anthocyanin?
Can you say that one more time, please? The question.
What do you think about the influence of the compounds other than anthocyanin? Maybe many compounds would be involved in your.
Its structure influence its color. So just like this structure, its colors will in red, and this will colorless, and this structure will in blue, and this in yellow.
Thank you.
ありがとうございます。その他ご質問のある方いらっしゃいますでしょうか。はい、では中澤先生、マイクをお願いいたします。
Thank you. You prepared a new test strip from the butterfly pea flower. Let me ask you about the durability of your test tube against temperature and oxidation. How long can you use the test tube? For example, 1 month later, you can still use your test tube, or it's decomposed or something like that.
The test tube will moisture after 1 month.
1 month.
Yes.
So
And if the
can
liquid,
you use 1 year after 1 year after you prepared the
we
test
haven't put the test paper for that long time.
tube? Okay. Is it the oxidation or temperature dependence? For example, you can use your test tube in desert, 40 degrees or something like that.
We can't understand the words you said. This sentence.
Okay, thanks.
Thank you.
ありがとうございます。その他ご質問のある方いらっしゃいますでしょうか。いければ、それでは、ご質問内容ですので以上とさせていただきたいと思います。台湾の台北ミニシパルリーシャンハイスクールの皆さんでした。ありがとうございました。Thank you very much. ありがとうございました。